Section 1.2 Rational Exponents. In this section we're going to continue with the idea of exponential numbers, except if you recall, when we defined exponential numbers we said that the exponent of the power had to be a natural number. That means it had to be a positive integer. So it could not be a decimal, it could not be a fraction, it could not be a negative number, it could not be zero. In this section we're going to extend that idea by taking a look at rational exponents. Rational in math is just a fancy word for fraction. Always remember that. You will see the word rational throughout this course. Anytime you come across that word, just remember all it means is a fraction. So we're going to take a look at that. How do we deal with exponential numbers where the exponent is a fraction? Okay, so that's what we want to do today. So let's get started. Right? So we're going to define a rational exponent as this. We're going to say that if n is an even positive integer, that means it's a whole number, okay, and b is greater than or equal to 0, okay, then b to the 1 over n, okay, is the non-negative real number such that b to the 1 over n raised to n is equal to b. Okay, so that's one way to look at a rational exponent. You can see my exponent now is a fraction. Okay, so we say if n is an even positive integer, whole number like 2, 3, 4, 5 and so on, and b is a positive number, then we define b to the 1 over n is a non-negative real number such that b to the 1 over n raised to n is equal to b. And you can see that if I were to multiply this using exponential property that we learned in the last section, you'll get 1 over n times n is just 1. That's what we end up with. Okay. There's another way to, and that's just for the even one. Let me go ahead and give you the other definition for odd, and then I'll give you a different definition. If n is an odd positive integer, okay, then b to the 1 over n is the real number such that b to the 1 over n to the n is equal to b. So what this tells you is that we don't have this requirement anymore. When we have odd when n is odd, we don't have that requirement. B doesn't have to be positive. It can be anything. When we say b is greater than or equal to 0, we're really implying here that it is positive, because when numbers are greater than 0, that means they're to the right of 0 on the number line, so they're positive. So that's one way to define this. Another way we could have defined this is we could have said that b to the 1 over n is equal to a, okay, if a to the n, if a to the n is equal to b. So there's another way to define exponential number, a rational exponential number. So we say b to the 1 over n is equal to some number a if there exists a number a such that if you raise that to n, you get b. So let's take a look at some examples. So there are some couple definitions I've given you. Okay, so let's take a look at an example. So let's say if you have 25 to the half. So 25 to the half will equal to some number. Okay, we're looking for that number. If we can find that number and square it and get 25, and you can do that in your head, you can see that we're going to end up with 5. Okay, now keep in mind, if I were to take minus 5 and square it, I still get 25. So you might be tempted to put minus 5, but remember what our definition said, okay, that if b is greater than 0 and n is even, in this case n was 2 in this example that I just did, then b to the 1 over n is a non-negative real number. That means it cannot be negative. That's why we cannot have minus 5, even though minus 5 is equal to 25. When n is even, we cannot have that. Okay, here's another example. Let's say you have negative 64 raised to 1/3. What is that? Well, if we can find a number whose cube is equal to negative 64, can you take a number and multiply by itself 3 times and get negative 64? Sure, the number is negative 4. Negative 4 times negative 4 times negative 4, we get that. Here's another example. How about 16 to the half? Can I find a number whose square is equal to 16? Sure, the number is 4. And one last example. How about negative 36 to the half? Okay, can I find a number when I square it, since n is 2 here, and get negative 36? Now think about it for a while. Anytime you square any number, we end up always with a positive number. When we square any number, we'll always end up with a positive number. So is there any way to get a negative 36 out of it? No, that's not possible. So this is not a real number. So to evaluate numbers when the exponents are rational, all we have to do is basically look for numbers raised to that n value that you're taking the rational number to, and see if you can find such a number. So and I've given you some example. Let me just do one last one before we move on. Okay, let's say you have minus 32 raised to 1/5. The only time you have to really worry about is when n is even, when that denominator is even. In this case it's odd, so we can do this. I want to find a number. If I take it to the 5th power, since n is 5, I end up with negative 32. And you can play with those numbers in your head. It's negative 2, because negative 2 times negative 2 5 times is negative 32. Okay, so I gave you some examples of rational exponents here, and I also gave you a couple definitions to look at. Let's take a look at some properties of properties of rational exponential numbers. I'll abbreviate this exponential numbers. Okay, so first of all the properties that we've done so far are good. So let me write down, I'll just write down, put a note, all the properties of exponential numbers from section 1.2 apply. Okay, so all of those properties that we talked about in the previous section, from 1.1 apply. That means, let me just quickly refresh your memory. We don't have to worry about the first property, because if the exponent is 0, it's no longer a rational exponent per se. It's not a fraction, so we don't need to worry about it. We just get 1. And all the other properties, like we had n times this, was b to the n plus m, if you recall. So now we have 1 over n times b to the 1 over m. Well, it will be b to the 1 over n plus 1 over m, and so on. So all of those properties are good. So everything works, except we have one new property that we need to worry about. Okay, so let's take a look at that. So that's this property. So if you recall, last time I had 6 properties, so I'll call this number 7. Okay, so that property was this is the new property that we need to worry about. If you have b to the 1 over n raised to m. Okay, so let me write it this way. That might be b to the m over n. Now I can write this as b to the 1 over n raised to m, or I can write it as b to the m raised to 1 over n. And the reason for that is because according to the property of exponential numbers, I can multiply this and get this back. Same thing, I can multiply this and get this back. So it doesn't matter which way you look at it, they're both the same. But one is better than the other. It's always better to do this when you have this, because whenever you do this thing, the numbers are going to get smaller, and you can see that over here. When the exponent is rational, the numbers get smaller compared to what you start with. So we always want to do that first, okay? Because if I do this first, anytime you take a square or a cube or a fourth power or the fifth power of a number, that's going to get bigger and bigger. So it's going to be harder to do the 1 over n of that number, whatever we get. So it's better to to make the numbers smaller first before you take the power. Okay, so that's the one we always want to do. So I'll give you some examples of that. So that's the only new property we need to worry about, and then I'll do some other simplifying examples in a second. So let's say if you have 64 raised to 2/3. Okay, let me show you the wrong way to do it. You might be tempted to write it as 64 squared raised to 1/3, because if I multiply 2 times 1/3, I get 2/3. And then 64 squared, I myself don't know what it is. I'd have to do it on a calculator. And then whatever we get, we want to raise that to 1/3, so that you can see it's going to get ugly very fast. So let's do it the other way, the better way, the one I've boxed up here. We first take 64 raised to 1/3 and then square it. So let's just do that on the side. Let's just do this inside on the side here. So I want to find a number. When I raise it to 3, I'm going to get 64. And the number happens to be 4, because 4 cubed is 64. So the inside of that is 4. And then you square that, so you end up with 16. So you can see that's a lot easier to do than trying to do the square first. Here's another example. Okay, let's say that we have 25 raised to minus 3/2. Okay, the first thing we'll do is, because we know we can never have negative exponents, let's fix that. So we get 1 over 25 raised to 3/2. We'll make that exponent positive. Then, if you recall, what do? We have a choice. Should we do the cube first or the 1/2 first? Let's do the 1/2 first. We've talked about that. 25 raised to 1/2, and then you cube it. So we get 1 over something cubed. So let's do that on the side. What do I want? I want some number. When I square it, I get 25. What's that number? Because 5 squared is 25, so 5 goes here. And then 5 cubed is 5 times 5 times 5 is 125. So the answer to that 25 raised to minus 3/2 is 1 over 125. Okay, here's another example. Let's say we have negative 27 raised to 2/3. So once again, I'll take negative 27 raised to 1/3 first, and then square it. Now I have to be careful here because there's a negative inside, so I want to keep those parentheses. That's why I put extra set of parentheses or brackets, whatever you want to call them, on the outside. So I do this first. So let's do that on the side. I want to find a number whose cube is equal to negative 27. So let's do that. So you can see negative 3 cubed is equal to negative 27. Negative 3 times negative 3 times negative 3. So this inside happens to be negative 3, and then you square that. So negative 3 times negative 3, when you square it, we get 9. So that's the answer to that problem. So I hope I've convinced you on how to calculate numbers that have rational exponents. Okay, let's go ahead and do what we did before in the previous section about simplifying. So let's do that. Okay, so we're going to do simplifying exponential expressions. So this is going to be very similar to what we did before. Make it simple. The expression might be ugly to begin with. We just want to make it easier to read, so it's easier on the eyes. Okay, we just have to be careful though when we do this, because the steps that I gave you last time are good, but we need to come up with some better steps. Okay, just we need to make one little slight modification to our previous steps. So let's take a look at it. So let's say if I have, let's start with something like this. I have a raised to 2/3 b raised to 1/2 cubed divided by a raised to minus 1/4 b raised to 2/3 squared. So now you can see it's a little bit more complicated because my exponents are fractions, but the idea is still the same to begin with. We start by taking care of this outside exponent like we did in the previous problems. So let's do that. So you take 2/3 times 3. So if you do that, and you'll have to do a lot of work on the side in these problems. So let's just do that. If you take 2/3 and multiply by 3 over 1, because this is over 1, the 3's will cancel, so you just get 2. So we get a raised to 2. Then you take 1/2 times 3, so you get 3/2. In the denominator we get minus 1/4 times 2, because we're going to multiply these, over 1, so the 2 cancels here. So we get minus 1/2. So we get a raised to minus 1/2, and then get b raised to, we have 2/3 times 2, so we get 4/3. Okay, so that's what we end up with. That's great. Now, if you recall what we did in the previous one, we just started canceling. But it's really hard to cancel things when the exponents are fractions. But before I cancel, I have to make negative exponents positive. So this one has a negative exponent, so it needs to go to the top. So we get a squared b raised to 3/2 a raised to 1/2 divided by b raised to 4/3. So now it's really hard to cancel these numbers here with b's because it's hard to cancel fractions. So it's important that when we are working with exponents that are rational, instead of canceling, we just move everything to the top. Even if it's not negative, we move it to the top. Okay, so that's what we want to do, and that's one way to tackle it. There's other ways you can do that, but I prefer moving everything to the top. It's just easier. So you get a squared a raised to 1/2 b raised to 3/2 b raised to negative 4/3. Okay, and then we can use the properties of exponential numbers. I'm multiplying two exponential numbers with the same base. I can add the exponents. So we have 2 plus 1/2. Anytime you're adding fractions, we need a common denominator. In this case, the common denominator is 2. So I'm going to have to multiply this by 2 and 2 here. So we get 4 over 2 plus 1/2. This one already has a 2 as a denominator, so we get 5 over 2. So we get a raised to 5/2 plus b. This time, and I'll do all the scratch work on the side. That's the best thing to do. We have 3/2 plus, minus 4/3. Out here we are multiplying two exponential numbers with the same base, so we can add these exponents. That's what we're doing. Out here the common denominator is 6. So I'm going to multiply this by 3 and 3 and this by 2 and 2 to make them the same denominator. So we get 9 over 6 minus 8 over 6. So we get 1 over 6. 8 minus 1 is 1. So we end up with 1/6. And there's your answer. Okay. So what is different about simplifying rational exponential numbers? All you have to remember is, because we cannot cancel, once we take care of the outside exponent, all we need to do is move everything to the top, combine whatever you can combine, and if then you have any negative exponents left, you move them all back to the bottom. Okay, so let me go ahead and do one more example of this, and then we'll be done with this section. The next section, which is on radicals, will be an extension of this, so it'll be easier to do. So let's take a look at another example really quick. So let's say that if I have a raised to negative 1/2, b raised to negative 1/4, c raised to 2/3 squared divided by 4 times b raised to 2, c raised to 3 raised to 1/2. Okay, so let's take a look at how to do this. Again, you can see exponents are rationals, they're fractions. So the first thing we do is, as always, take care of the outside exponent. So let's do that. We get a raised to what? You multiplied this and this. So we get negative 1. B raised to negative 1/2, because you take negative 1/4 multiplied by 2. 2 cancels, so you get negative 1/2. And you get c raised to 4/3. In the denominator, we get 4 raised to 1/2, b raised to 1, c raised to 3/2. Okay, so we're just distributing those exponents. Alright, so now what did I say to do? Move everything to the top that we can combine. These two can go to the top. Now the 4 doesn't need to go to the top because that already has a positive exponent. We can just take care of that. What is 4 raised to 1/2 equal to? We want to find a number whose square is equal to 4. So the number is 2. So this really is just a 2. Okay, so we just need to move those two things to the top. We don't need to move that 2. So we get a raised to -1, b raised to -1/2, c raised to 4/3, b raised to -1, c raised to -3/2 over 2. So now let's see what we can collect. This and this can be combined because we are multiplying and they have the same base. We can add those exponents. So we have 1/2 minus 1. The common denominator is a 2, so I'm going to multiply this by 2. So we get negative 1/2 minus 2 over 2. So we get -3 over 2. So we get a raised to -1. That stays there. There's no more a's. B raised to -3/2. Same thing with c now. Let's do c. I have c term here and here. They're the same base. I can add the exponents. So we get 4/3 minus 3/2. The common denominator is 6. So you multiply this by 2 and 2, and this by 3 and 3. So we get 8 over 6 minus 9 over 6. So we end up with -1 over 6. C raised to -1 over 6. And again, you might think you're done, but remember, we can never have negative exponents, so we need to move all the negative exponents to the bottom. In this case, all of them have negative exponents. So when we move them to the bottom, there'll be only a 1 left on the top. We have 2a, b raised to 3/2, c raised to 1/6. And there's your answer. Okay. So when you're working with rational exponents, that's what you want to do. It's a little bit different, just a slight bit. Once we take care of the outside exponent, what we need to do is move everything to the top, all the terms, and then we basically add the terms, add the exponents where the base is the same, and then if there's any negative exponents left on the top, we move them back to the bottom. Okay. I hope this helped. Just take a few minutes and do your homework from that section. That way you can practice some of these concepts that we just talked about.